Welcome to Career Month by Globant. Get ready to dive into meaningful conversations about what's coming next in tech trends and careers. We'll be starting soon. Career Month by Globant.
Hello, everyone. Thank you for joining me in this SwiftUI workshop. It's a pleasure to be part of the 2023 Career Month edition. My name is Alejandro Vallejo. I come from Argentina. However, I'm currently based in Madrid. I work as a mobile technical lead as part of the engineering studio at Globant. And for those who are not familiar with Globant yet, we are a worldwide company that initially started in Argentina. We have 25 countries, and we are almost 30,000 Globers. Yeah. So we are mainly running into digital transformation with our clients. Yeah. So that means that we are not only providing technical solutions, but also helping them to embrace the constant changes of technology in a healthy and competitive way. Yeah. So a little bit of my mobile background. So I've been doing apps since iOS. I think it was 3.5 in 2012. So for more than 10 years, and I joined Globant 8 years ago. And since I started to work here, I've been leading a mobile project. Yeah, so I had the opportunity to help massive companies making choices around technology. Yeah, and I have also been part of the evolution of long-term mobile products. Yeah, so I got used to going through technical analysis and making decisions around solution design. Yeah. So right now I see a very good opportunity to create meaningful and positive impact in the world. I mean, not only Globant. Yeah, everyone that is working in technology is having a very good opportunity with this the AI era that we are going through. We are changing the way we think. Yeah, and there's a lot of new needs that we need to shape, and I think mobile is key for creating that bridge. Yeah, with all the new features that are coming. Yeah, so we are in everyone's pocket, right? We are in the watches, TVs, car. Our practice is growing a lot. Now with vision, we will be the virtual reality as well. So I think we have a privilege to reach audiences in ways other technology don't. Yeah, mobile in general, I'm talking about, right? So we need to be prepared always. And it's a big responsibility. So a little bit of context. We are in the current month edition. This is a month-long event that you can use for stay one step ahead in your career. Yeah, so there's a lot of talks around technology topics that are great, and this will be for the whole month of October. Yeah, we will leave you in the chat the link if you want to check info for other sessions. Yeah, so let's begin. If someone can send me that we can see the PPT, is that fine? Perfect, awesome. So the agenda for this session will be an intro, which we will review a little bit what is SwiftUI and the comparison with UIKit. Then we will move to technology awareness. Now, this is something that I want to share with you. I think with a strong foundation, knowing what is happening, I think we can reduce false step going ahead with this technology. Yeah. And then we will have some, I would like to review some gap that I think we have points, weak points on the understanding that we can review. And I think tomorrow we will wrap everything and put it into a base SwiftUI project. Yeah. So let's begin. So for those who don't know, we are running into a transition. Yeah, we are changing the way we are building interfaces. Yeah, and this is not only for iOS. On iOS and on Android, we have the transition from XML to Compose. Here we are moving from UIKit, AppKit, everything Kit to SwiftUI. Yeah. Um, and here we have a quick description, a high-level description on how this the mindset switch that we are doing in our practice. Yeah. So before going into details with this, we know what this is about. Yeah, we are used to doing some transitions on the way of work. Yeah, we already have the transition from going to Objective-C to Swift. Yeah, and Android from Java to Kotlin. Yeah, of course this is not that big, but it still requires this mindset change. Yeah, so this is let's review quickly this list. Yeah, and we will deep dive later in what the graphics are about. Yeah, so first, UIKit was built compliant to the object-oriented programming world. Yeah, we live in an object-oriented programming world. So views are represented with classes. Yeah, in the code. Yeah, so it's compliant to that implementation. Yeah, and you know that whenever, or I hope you know, but whenever we are instantiating a class, we are keeping a reference. So that is why we are calling it a reference type. Yeah, and we have also a protocol-oriented programming. Yeah, that we are using everywhere. Yeah, protocol is the neatness of Swift. Yeah, we have this thing that is similar to the interfaces for the ones that are not familiar to the iOS practice. We have the protocols that are connecting all the types that we have in Swift. Yeah, this is an abstraction for that describes a behavior. Yeah, and it's whoever is implementing that protocol needs to use a contract. Yeah, it's similar, like I said, it's similar to interfaces, but we have several things more. We can create properties in our protocols, and we could have default implementation. So it's more like it's something that we used to do with base classes, but now we are doing it with protocols. Yeah, so we don't have that in SwiftUI. Of course, yes, protocol-oriented programming, but we are not using object-oriented programming. We are using functional programming. Yeah, this is something that I will tell you a little bit more later. But there's a lot of sessions, and I think we had one this month related to that. But basically, here we are not using classes. Yeah, we are using structs. Yeah, and structs are value type. That means that it's pointing to a value in the memories. Yeah. So then we have imperative programming for the UI on the UIKit. That means that we need to provide instructions to perform every task. Yeah. In SwiftUI, we don't have that. We are declaring how a view will behave for a state of a piece of data, and then in runtime, whenever the data change, it will switch the view. Yeah, we have these processes are stateless. Yeah, so whenever something needs to change on rendering, it will be destroyed and redrawn. Yeah, for every single change on the data side. And then we have event-driven programming in UIKit. Everything is related to events. On the app cycle, we have a callback from the outside world, yeah, with our app delegate or scene delegate, yeah. We are receiving events, so we are coding inside those events. Our app process is right there, yeah. Um, Also for every time that we are containing a view in the window, you will receive the callback for the view is low, will appear, and stuff like that. So everything is started with an event. Yeah. So and for SwiftUI, we are reacting whenever the data change. The view will behave like you described on the code. Yeah. So now I want to deep dive on 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 these graphics, yeah, and talk about classes, yeah, because this is a huge improvement, yeah. And sorry for non-technical people, but this is going to be actually it's a little bit hard to explain in a short period of time, but I try my best and I try to keep it super simple. But I wonder how to share one tip that is helping me a lot, yeah, and it's been built with a lot of experience behind, yeah, and also there's a lot of great content right in internet, and I wanted to provide something that you don't have that and on those, and I didn't found uh, this concept. I will provide you a statement and I will explain a little bit what it is. So this is another way to define SwiftUI. Yeah. So Swift SwiftUI is also one step forward in running out of implicit sharing. Yeah. So let me explain you a little bit what is this about. Um, First, we need to understand that an app, a program, uses memory share spaces between what is dynamic and static. Yeah, we are calling dynamic for the things that are allocated in memory at the runtime. Yeah, for example, a class. Yeah, you are you are creating instances of your classes whenever your app is running. Yeah. And then you will have the static, that is the processes that allocate memory at the compile time. Yeah, those two those two types of allocations has different characteristics. Yeah, and we are calling a stack to the partition in RAM for allocating the compile allocations, and we are calling heap to the partition in RAM that is allocated in runtime. Yeah. So the the structs are using stacks, yeah, and classes are using the heap. Yeah. So keep that in mind, and I will explain implicit sharing in a minute. But this is key to understand how big is this change. Yeah. So there's a lot of benefits that you have whenever you use the stack memory. Yeah, it's super fast comparing to the heap memory. It's you have only one stack per thread, so you cannot share data. The memory on the stack is not being shared through the threads. That is super convenient for having the UI, right? We also have it's something that can be measured on the compile time. So something that is um, um, good to know whenever you are coding and and the code is not compiling. Sometimes you are trying to put in a stack something that is not measurable, so the compiler cannot allocate it in memory. Yeah? Um, so given that this will be allocated in compile time, it cannot mutate in runtime. Yeah. So if you assign a property, and we will see it in a moment, but if you assign um, a property bar to extract and try to change that value, it won't work. Yeah, but you can compute the value at the initialization. Yeah, so that is a stack, and the heap, how it works. Yeah, so whenever you create a class, and you instantiate a class, sorry, you are holding a piece of memory on the heap. Yeah, that is called a reference. Yeah, and there's a on the implementation for classes in a language, it has implicit sharing. That means that that piece of data can be held for any other process. Yeah, so um, that could be great for a couple of things. Yeah, so you're having a very efficient usage of memory. Yeah, because you can reuse the data with different processes. Yeah, but this is opening the Pandora's box. Yeah, so this is like our nemesis for object-oriented programming. Yeah, because um, we could have like race condition. That is when uh, multiple processes want to access the same resource. Yeah, and we are using logs maybe for preventing that, and that is decreasing the efficiency because your process need to wait that someone else release it. Yeah, so you could have deadlocks. That is one resource that you may want with the process and it's being handled, but another one that is holding that is waiting for another one that owns the first one. That is a deadlock. That is memory that you cannot use anymore. Yeah. So uh, um, and this is having a lot of complexity in our practices. Yeah. So working with classes. Um, I've been working with UIKit for 10 years. So I feel confident on the stability for creating a complex UI. Yeah. But maybe for a new developer, it could be overwhelming. Yeah. Of course, we have the knowledge to do it great, but even with all the knowledge, it's not 100% guaranteed that you will we will you will not have memory leaks. Yeah, it's impossible because mobile is a hostile environment. Yeah, you have unwanted intents all over the place. You have the user, bad connection, I don't know, out of memory. So, and given all the multiple threads using this memory, it's it's a problem on the performance. Yeah, it will decrease your performance. You cannot prevent that your performance will decrease um, going for a long time. Yeah, so that is why this improvement is changing so much the way of working, because for the presentation layer, I mean, all the things that are related to presenting the data to the user and interacting with the user, classes are gone. So there will be all the memory leaks that we had in this whole bunch of code doesn't exist anymore because now it's using structs on the stack memory. Yeah. So it's a huge improvement out of the box. And actually, a junior developer and a senior has the same performance. Maybe it's not the same on the maintenance side, right? Uh, by the way, you can break down your code as you want, and you will have any loss of performance. Yeah, because like I said, this is allocated in compile time. Yeah, so whatever you have as a code, the compiler will optimize it and put it in the best way for being allocated. So that is, I think, one of the most important thing that I wanted to share with you. I hope it makes sense. Yeah. So let's move forward, and I promise we will jump to the code. So this is the main differences. Views are value types. Like what I have shared. Multi-platform support. SwiftUI is providing you support for all the platform. Let's have in mind, and let's be honest, it's a work in progress, but there's a lot of benefits and great workarounds that are giving you um, a, a good feeling that if you adopt it, things will go well. Yeah, at least on my experience, went well. Yeah, but I mean, there's several things. If you are doing TV apps, a couple of things you need to go to UIKit, AV Foundation, that is super required. We need to go to UIKit. So there's a lot of things that we're still missing on SwiftUI. Yeah. Code legibility and maintenance, we will see it in a minute. It's actually designers can jump in and fix things on accessibility side, on resource assets, stuff like that. On the maintenance side, the designers also are choosing SwiftUI for building things from the scratch and seeing it working. So right out there, are amazing apps that designers are creating. Yeah, because it's super simple. Yeah, not only SwiftUI Compose is also a great tool, but it's even simpler than CSS, right? So yeah, they are doing great things. We have building binders, and SwiftUI is managing the state, and we have building animation as well. So this is what represents whatever I have been talking to you. So this is how it looks, a view on UIKit. Blues are views, yeah, purple controllers, greens data. You have here something that is super familiar with us and all the references and dependencies. That is, is what we have. That's fine. But this becomes super simpler in SwiftUI. Yeah, you only have to describe these views for a piece of data, and SwiftUI will do all the rest, the binders, the combine behind to have the publisher subscriber. So let's go to the code. So one important thing. Maybe I'm not seeing the chat in runtime, in real time. Sorry. So if you have any question, we can I can take it at the end. Yeah. And if we are not having enough time today, we can review it tomorrow. Yeah. How we are so far? Okay. Okay. So let's go to ESCO. So this is a new project. Yeah. This is how SwiftUI looks. Yeah. This is the preview. The point is not doing a review for the tool. I'm supposing that you already know, but you have a lot of great tutorials and people describing this tool much better than me. But the key point is that the preview is also working with UIKit, by the way. But you have an instant feedback for color scheme. So I think this should be a part of the PR review, right? Sending a screenshot on how the color appearance looks like, orientation, yeah, and also dynamic types. Yeah, dynamic types is critical, and we only need to take a screenshot of this, and you know if your app is complying. Then you have this great tool that if you so you can take advantage for the inspector. Yeah, if you select on the code or in the view, you can see the properties, and actually change things right here. If I want, for example, this to be bold, I can set font here, and I have all these things are property extensions, yeah, and I can yeah on font yeah. Yeah, it's easier to do it on the code, but I want to show you that anyone without development knowledge can also play a little bit with the tools. Yeah, and this is important. We have no excuse, guys. We have the accessibility labels are right here. You can even extend it and describe how accessibility will work on the views right away, right here, and you don't need to be a developer. Yeah, everyone can do it. Yeah, so that for you to keep in mind. So let's review a little bit the code. A couple of things that are important to know. Of course, we are using structs. Yeah, this looks like a class for someone that is not on the practice, but this is not inheritance. Yeah, this is the implementation for the protocol. So this is saying that content view conform the protocol view. Yeah, and it has a contract. Yeah, that we need to we have to implement as a requirement. Yeah, if I'm commenting this line is complaining because of that. Yeah, so the for you to implement the protocol view, you only need to have this property. Yeah, this is a computed property. Yeah, the computed property is the one that whenever you want or you ask for, it will execute this code. Yeah, and these are all functions. Yeah, these are all functions. Yeah, image is executing this function. I will return something that behaves like a view. This will uh, um, return something that behaves like a view. And this sum, what this means. So the property body needs to implement something that behaves like a view. Yeah, and I can do I can do this. I know that, for example, text is behaving like a view, so I can do this, and this is fine. Yeah, this will be update the view, but and I can add I can execute functions that will modify my view. Yeah, what we were seeing is, for example, font. I can make it title, font weight. I can put bold here. So this is changing this view, but this still returning a type text. Yeah. I didn't mention, but Swift is an strongly type programming language. Yeah, everything should have a type. Everything. That is why generics are so important. Yeah, but so that is something super important, and I don't need to do this. Yeah, I don't need to specify what type is this because we have type inference. Yeah, that means that the compiler will know what type is this var because of what this is returning. Yeah, and what happens if I'm doing this, for example, I will say that this is a computed var, the type of text. Yeah, it works. But what happens if I'm doing this, right? This is returning something else. Yeah. Okay, so this is returning an stack with the text inside. Yeah. So I cannot change this building my views. So what is, so I could say, okay, so this will be any view. This won't work because any, it's saying, no matter if implements the protocol, if conform the protocol, it's fine. That won't work because everything should be measurable at the compile time, yeah, for the stack memory, yeah. So this is not measurable, okay? Sorry, because we don't know what contains, yeah, because this is a protocol implemented by I don't know, could be a class, could be an struct, could be anything, yeah. So some is saying to the compiler, hey, whatever this return, put it here as a type. That's it. Before compile, check what type it is and put it here. That is that what some means. Yeah. So let's look into a little bit of the legibility that the code is having. Yeah. So something that is super easy is to tell what we are describing as a view. Yeah. If 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 we want, for example, to have a list of these, you can we can create it quickly, and we can change this as an horizontal tab. We can put it in a list. Yeah, I can modify the style of the list. I can add a navigation title. Yeah, I need to modify the title. So this is super easy compared with UIKit, yeah. But we are missing the other part. What happened with the data, yeah. So let's do a quick sample on how to connect the data, and then we can move to other things. So we are doing like a quick review. So let's change this by a property called items, the type of array of strings. Yeah, this is another thing that is good on the legibility side. This is the same as putting array with this type. Yeah, so there's a type like that are all over the place with Swift, and is giving us a nice um, code legibility. Yeah, and same for this is returning a value. Yeah, so this is the same as put return, but the um, the editor is removing this, is using it on in the compiler. Yeah, but not for us. So we can, if we have return, it will be difficult to understand the views. Yeah, so let's create this with the default value. Yeah, and the default value will be a range from 0 to 5. We will map this. Um, another thing that you will see all over the place is that whenever you have as the final parameter a closure is a function in line. It's just a function that you are calling in line of something. Yeah. So whenever you have the final parameter is a closure, you can remove the parentheses this and put the and put the brackets, and it's more clean. Yeah. And yeah, this is saying that I have I need to return something. Yeah, so I will create a string with item. I will use string interpolation here to use, and whenever I'm in a closure uh, um, that is in a loop, I can use this expression to get one item from this range. Yeah, if I'm mapping a range, it will iterate for all these values. Yeah, and with this notation, I can have the value for that iteration. Another way to do it is like this. Yeah, I can do it like this. It's the same thing. Yeah? Oh, so we have these items. Yeah, let's put it here on for each, and this will require also an ID. If I'm using int, this is not required, but for array of strings, for each string, I need to set an ID, and this is providing the the key path of the hash of the value that I'm iterating. Yeah. Okay. So I have my string and okay. So let's add here. Let's grab this into a navigation link. So I can set this view this, and I can go to whatever behaves like a view. Yeah, I don't need to in UIKit. I need to instantiate a view controller and set the view and put it here, right? But since everything behaves like a view, whatever behaves like a view could be the next screen. Yeah, so you can put whatever you want here. So I will put this text. Sorry, with the item. So now I'm I have a lot of things out of the box. Yeah, using navigation link, the accessory indicator is right there. Um, if you see the transition, the title goes to the back. Those things are built in for this particular controller. Yeah. So that's one thing. If I'm let me I will add a button and add an item. Yeah. So we can see how the data change works. So I want to do it below the view. Where we create okay. Well, okay, and so this so I will append. Sorry, new string. Yeah, and this will not compile. Yeah, for sure, because we cannot mutate. We cannot use the properties of struct. Sorry, this is items. We cannot use the properties of a stack um, for having a different behavior on runtime. Yeah. So I need to tell SwiftUI that this is a data that uh, that I want to use as control for this particular view. So we are using property wrappers. Yeah, that are the ones that start with add. Yeah, and I will say that hold this data for me. Yeah, and whenever this change, redraw my view. That is what I'm saying with this. And I'm using state because this is a value type. Yeah. That means that this is also a value type. This is also in the stack memory. Yeah. If I'm using a reference type, I need to use state object. Yeah. There's other ways there's other property wrappers. Yeah. I will use another one in a minute, but um, this is important. Let me tell you one more thing about uh, technology awareness. So I don't know if you remember, but we were on the very beginning. We whenever we started to use Swift, we started with these values. Yeah, this is an object. Yeah, and sometime later we remove this. Yeah, that was another another transition to the stack. Yeah. So Apple what did is all the types that we had, all the primitive types that we have with referent types, we move it to the value semantic world. Yeah. So we with that improvement, with that change, we also reduce a lot of memory leaks and all the things that are happening on the heap. Yeah. So that is for you to keep. So it's always the same. We are reaching like an excellence point uh, for solving the complexity, and Apple is releasing a tool that makes everything easier. And again, and again, and again, again. Now we are doing it with the views. Yeah. So let's do one thing. Let's put this into in a subview, and let's put items view. Yeah. So this is having no cost. Yeah, breaking down the code is having no cost because the compiler will put it everything together in, I don't know, a sequence of data. So you cannot break anything on the performance side for breaking the code in pieces. Yeah. So let's do this. We need items. Yeah, in this struct. So let's create this property here, and let's say that this will be an array of strings. Yeah, and this is another accelerator. The editor is creating the initializer for this property. Yeah, and instantly is asking us for that parameter here. That is not happening with classes. Of course, you have accelerators as well with classes, but classes can mutate. So, but this should have a value. Yeah, all the things that are allocated in the stack needs to have a value. Yeah. So I want to give these items. This is so this is passing the value to this view. Yeah, and and it's and it's saying, yeah, use this as a copy. Yeah, this will copy these items and will use it. Yeah, but if I want to do things with the data and and make the changes all that impact also in this one, I need to pass this value as and the way I'm passing that is like that. Yeah. So whenever something changes here, it will impact here. Binding is saying, hey, I'm not the owner of this, but take these changes. Yeah. Okay. So this is good. Let's let me tell you one more thing. right now, Apple is doing another type of bindings, yeah, with observable, yeah, and it's making sense. If you are doing SwiftUI right now, it's getting a little messy, putting all the publishers and the property wrappers. So it makes sense for them to set up something that you want to observe, and that's it. Yeah, you don't need to take care about the publisher in every single property. Yeah. So if I'm tap add item, I will have the new item. Yeah. So this is instant feedback for the actual behavior in runtime. Yeah. This is great. Yeah. This is great. Um, so this is, let's do one more thing and before switching to other thing. Let's make this a lazy grid. Yeah. Let's do a vertical grid. We need to specify the grid items. Yeah. So this vertical grid, you can add, let's say that we, sorry, this is the value functions. Sorry. So this is the way um, how we are building grids. Yeah, but there's a problem. Let's say that we have 50 50 items. So this is not scrolling, yeah, because the lazy grid doesn't come with the scroll. So you need to add the scroll. So now it's scrolling. And in the same way, we can have an horizontal grid, but we need, instead of, we need the rows. Yeah. And yeah, this is okay. Okay. And this, yeah, and it's not scrolling because the default value for the scroll is vertical. Yeah, so you need to specify here. Now this is scrolling. Okay, so this is how you build things with SwiftUI. Yeah, and if I want more, I can. I only need to choose the right data. Yeah, and related to the UI, for you to know, honestly, I think the next year we will not creating the views because the, right now we have plugins for Figma that exports the code for SwiftUI. So it's like, I really think that we don't need to worry about the UI. It will be super easy to do. So yeah, I will not take time for doing things. I'm not that good on those things, but I think giving you like a quick snapshot on how building things in UI looks like, it's good. Yeah. Well, so let's review another thing: interoperability with UIKit. Yeah. So let's do this. Let's start again. Yeah. So first, let's create a view controller. How we are? Can you hear me? Oh, there are a lot of questions. Uh, okay. Okay, let's take some questions that we have here. So, um, yeah, so uh, how you share memory between processes? Let's do it. So, so let's say that we have. So, so the thing is that for your presentation, uh, you have the struct, right? But then a common way to share data is using your model for your view. Yeah, that should be light. Yeah, view model match really well. Yeah, so let's not think on the architecture pattern. Yeah, let's think on with the common sense. If I want to manage something on the data side for this view, I can create a light model. Yeah, let's call it. But I need a class. I need something that can be mutated on the runtime. Yeah, so I need a class. Yeah, let's call it view model, and I can take my property right there. Yeah, and here instead of, because this is a reference type, I need to say state object. View model. Okay, sorry. So now, um, yeah, I need to conform the protocol observable logic. Yeah, that is why Apple is so we are doing this a lot of time. Yeah, during the day, but sometimes you define a behavior with a protocol, and you don't remember all the expressions, and sometimes you take 2 more seconds because you figure out, oh, I missed that. Okay, so this will not let's change this, and sorry, this one, and this it will not work because I need to specify here that this will be property that I want to that one that triggers the redraw of my view. Yeah, so this is the the same thing. Yeah, sorry, I put this out, and let's keep only. Let's go back to the list so we can see everything. Okay, so if I let's put this, that should be fine. Okay, so this is working just like it was. Yeah, but now I'm in the runtime memory, right? This can be shared. This can be whatever you want. Yeah. This is my model. I can connect this in the same way you were doing with UIKit. You can call this model and keep your references tied to the maybe your domain logic. Yeah. So I use only one way to do things, and I repeating it. That is something that we will look tomorrow, but it's good to have one way to do things, so maintenance is easier, but it's difficult to keep the same way. But for views, I'm having a view model, and then it's talking with combine with other process outside the presentation layer, talking with the domain layer with combine. Sometimes I'm using only notifications, but something that is loosely coupled, that is not um, um, coupled with strong references, a strong reference. So maybe sometimes I'm listening things that are happening on the logic, and the view model react and do the changes on the data that the view is observing. So let's add here a view controller. Hopefully this snippet is working. No. Hmm. Yeah, so I have here a view controller. Yeah, this view controller. Let's. I don't have this. Let's put our view model. View model. Okay. 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 This is a view controller with a title, a button. Yeah, it's doing the setup. Yeah, let's create a text here. Another property. This is a property that don't change. Yeah, that doesn't change. Sorry. Um, let's text. Okay. I'm improvising a lot here. Hopefully, I'm not getting angry with me. So let's use this button to change. So let's see. I'm having yeah, sorry. We have here this view controller that is having only this a title and a button, and let's see how it looks. Yeah, so let's comment our view, and let's create another view with our UIKit view controller. Yeah, so we have that will be let's call it view. Yeah, and I need to conform. So for holding a view controller, I need to um, conform the protocol. Um, uh, is no, this not UI view. So Xcode will help me to be compliant with this protocol. I need to specify which is my view controller. My view controller will be view on sample. Yes, sample view controller. Yeah, and it will help me with the the function that I need to implement. Yeah, this one is for creating the instance of the view controller and putting it in a SwiftUI view container. And this is calling my my view controller whenever something changed. Yeah. So let's do this. Let's create here our sample view controller. Yeah. Let's put it in. And we need to return. See. So, and I need to pass. Let's do this. We are running out of time, so let's do it at once. So let's add the view model here. We need to pass the view model. That will be VM that I need to I can create here if you want. This is already SwiftUI world. Yeah, so I can do it here. This. And this is it. Yeah, so it will pass the instance of the view model. This will be passed to the sample view controller, and then there's one more thing that I'm missing. Yeah, so let me check. Yeah, this doesn't exist anymore. So let's actually we can see view here. Hopefully we will be able to see how it looks our view controller right now. Come on. Okay, so this is our VM text. VM text. this is great. Okay. So now we have our UIKit view controller. Yeah. So step for doing a migration, for example. And let's say that we have our view in SwiftUI. So how we can connect those processes? Yeah. So someone needs to hold the instance for the view model. Yeah. Maybe it's not if you are going to have both. Let's say let's go back with this here, and let's include in our view let's remove this, and let's put our BC view here. Yeah. So if you are holding in a container both views, it's fine to have it here. Yeah. So this is not. Whenever you are doing state object, you are saying I will be owning this instance. Yeah. But if I'm doing this, I will say that this view will observe this whatever is having as entry for the instance. Yeah. So I need to parameter, and that will be good. So let's uh, let's do this. Whenever I'm tapping here, sorry, I'm missing something. Yeah, this is actually, let's do this. Let's put it here. This is the last thing I will do, I promise. we can go back to the question. Yeah. So I don't want to hold this anymore right here. Yeah. So I will do this. Sorry, actually, sorry. This one, the one that is this one. I don't want to have this here. Yeah. Um, so I will. I can for this one. I can create a view model right here. Okay. So this is getting a little messy, right? So we should create another file for the view controller. Have the view model in another one. Yeah. But let's. If I'm changing it, so if I let's do this so you can see how SwiftUI works. Yeah. So let's add a label. Let's put as a title the text. So you can see that if I'm changing, yeah. So if I'm changing something on the data, since I'm saying, hey, whatever this data changing, whatever process, redraw this again. Yeah. So no matter which process in your app is changing that data, but if you are holding the same instance, that will be enough for this view to be redrawn. Yeah. So if I'm tapping, so this is in pause. Okay. Let's run because let's run it so we can use the instance for the app. Yeah. And let's see, let's review. I will clean up because this is so messy right now. Okay. It's taking a lot. Okay. So let me check because this is this should be my okay. Okay, so we are receiving the content view here, and we should see this change right away. And we can add this. We have another change. This is so let's analyze what is happening. So if I'm changing this is not sending any update because I so this is why Apple added the observable. Yeah, because you missed adding the published all the time whenever you are using SwiftUI. So this is changing this one, and whenever we tap here in the UIKit view controller, we are changing this. Yeah. So this is we are having a model that's been created in one part of the process. Yeah. This this is being held by SwiftUI, but we are keeping it in the app process for the app. Yeah. This is how the process starts. This is the entry port for SwiftUI. Yeah, and then we are passing that instance to our view controller and our view for SwiftUI. Yeah, and both are working fine. Whenever we have a change, we are receiving that change in our views. Yeah, for in the UIKit view, I need to specify, hey, if you receive what is yeah, I'm not doing anything on the UIKit, but if I applying, for example, the here on the target, I want to change something, I need to specify how should look. Yeah, how is the procedure to change the UI, and on the SwiftUI only reacts. Yeah, so I think we are out of time. Let's go back to the slides. 1 second. This, yeah. So we can finish the presentation. So yeah, so we were reviewing the property wrappers, building binders, yeah, with the proper for SwiftUI modifiers, and we didn't reach this point, but we will do it tomorrow. Yeah, we will view how we can describe different types of identity with SwiftUI, so we can handle navigation. Yeah, so that tomorrow we will talk about navigation. Yeah, and wrap everything in a base project. So the summary: we review some stuff for Swift, yeah, and SwiftUI. The composition, we have been doing some compositions for the view, UI support, and this is something that we will see tomorrow. So I don't know if you have a little bit of time, we can review the other question, because so sorry, I didn't have time to take a look on all of them. So let's do this. Let's stop here, and tomorrow we will start reviewing all the questions, and we will move fast. So I apologize in advance, because we need to go fast, so we can build something that works as a template for a SwiftUI project. Yeah. So that's pretty much all. You have here the QR code for the next session. Yeah. And that's all. Hope you enjoy this session. Please send me all the questions that you have, so tomorrow we can continue. Okay.
Career Month by Globant. Thank you for joining. Keep on boosting your career.